Good morning, good
Awesome.
afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. Today's event is being recorded, so if you miss any or all of the discussion, it will be made available for you to rewatch. You will receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We'll try to address as many questions as we can, so please send in your questions early. We also encourage discussion by using the chat tab. Let us know your thoughts, comments, suggestions, or just say a quick hello. I also want to point out that there are resources available for you in the handouts panel. And finally, at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. Stick around to see if you are one of today's 4 lucky winners. Let's go ahead and kick off our webinar today. Our topic is Scaling Kubernetes with Splunk and AWS. Joining me today is Pamela Carey, Sales Engineer at Splunk, and Tony Trin, Senior Solution Architect with AWS. Pamela and Tony, thank you so much for being here with us today. I'm going to turn the floor over to you.
Awesome. Thanks so much, Cody. So I'm just going to share my screen. All right, so welcome to today's webinar. As mentioned by Cody, the topic for today will be discussing scaling Kubernetes with AWS and Splunk. So just before we begin, I do have to put forward our forward-looking statement slide. It's a legal slide just around to not make any purchasing decisions based on the content of the slides today, as we may be referring to forward-looking statements. So just to introduce yourselves a bit further, so my name is Pamela Carey. I'm a sales engineer at Splunk. I've been with Splunk for almost 3 years, based here in the Melbourne office. And today I'm also joined by Tony. So Tony, I'll just let you introduce yourself as well.
Sure, thanks Pamela for having me. My name is Tony Trin, Senior Solution Architect with AWS. I've been with AWS for more than a year as well, working from the Melbourne office, supporting independent software vendor like Splunk in the ANZ region. So I work with Splunk on initiative like building out integration between our services or roadmap on new service or product, as well as co-market and co-selling activity.
Awesome. Thanks so much, Tony. So just to cover off, I guess, a bit of an agenda of what we're covering in the webinar today. So we're going to start by covering the state of container adoption in today's world. Then we'll look at some of the operational challenges that's involved with implementing distributed systems like Kubernetes. We'll then touch on key considerations in choosing a Kubernetes platform, which I'll pass over to Tony to discuss in further detail. And then we'll discuss how to gain essentially end-to-end observability and real-time monitoring into a Kubernetes environment and troubleshooting issues in real time by leveraging Splunk's observability suite. I'll go through some of our out-of-the-box content in relation to Kubernetes, such as our Kubernetes Navigator and the capabilities that we have within that solution. I'll then go through a live demo of Splunk's infrastructure monitoring solution and going through essentially a real-life performance issue. So we'll simulate that and go through essentially identifying and finding root cause related to that issue as well. As Cody mentioned, we'll have some time at the end of the webinar today to cover off some live Q&A, but we do have some colleagues from AWS and Splunk on the call if you want to use the Q&A panel as well. There's also some resources, as Cody mentioned, a number of best practices and white papers in relation to the topic that we've published in the handout section as well. So let's get into it. So essentially just covering off the state of container adoption today. So Kubernetes is continuing to be leveraged and continuing to be adopted by a number of organizations. So according to Gartner, 75% of enterprises will use containers, and Kubernetes will be the de facto standard. Essentially enterprises by 2022, 70% of them will be leveraging Kubernetes. And we've already seen a growth in adoption from 16% since 2016 as well. So essentially the net of this slide is that organizations are making a shift towards leveraging cloud native and containerized architectures, and it's continuing to grow each year. So firstly, we'll just cover off, I guess, a few of the benefits or essentially why customers are looking to adopt containers. And there's kind of, I guess, 4 key areas that customers have seen value from. Firstly, looking from a risk perspective, so being able to reduce risk and uniform security across the entire environment and maintain that with automation. So Kubernetes offers a rich set of controls in terms of securing the environment. So for example, network policies can act like firewall rules between each endpoint. And you can also isolate applications by leveraging namespaces within the deployment as well. From an operational standpoint, Kubernetes is self-healing in nature, and it continues to essentially reconcile its current state with its desired state and take corrective measures towards that. And essentially, as well as that, there is by deploying more workloads, you can leverage better resource and hardware utilization as well, which further leads to enhanced cost optimization. With speed, portability essentially leads to a lower time in provisioning new services and essentially delivering on new features or enhancements across your applications and your environment. And then from an agility point of view, automation increases speed and ease of testing and iterating as well. So essentially, with all of the key benefits that Kubernetes does provide, there are still some challenges that inhibit the adoption of Kubernetes specifically within production, and inhibit organizations in leveraging Kubernetes architecture deployment. So according to CNCF, complexity and security and monitoring were the top challenges that were identified, and especially when it comes to monitoring at scale. So 32% of survey takers found that monitoring was the top challenge, and particularly when that came as the deployment grew and essentially the enterprise grows as well. So if we were to look at scalability as the first challenge which we've seen of scalability, as we know, Kubernetes is a distributed system. So the creation of a single pod can create multiple Kubernetes objects, so 50 to 60 objects within the environment. And it can be very difficult to get visibility across all of the objects, as well as looking at your backend services and deployed microservices as well. On top of that, there also is a high cardinality of data. So the ability to split, slice and dice data by labels, tags and dimensions can result in a high cardinality of data, which makes it quite difficult for traditional monitoring tools to essentially provide visibility on, due to the constant churn of containers, as well as the rapid changing of the environment like ongoing. But before we look at the monitoring challenge, I will pass it over to Tony to discuss and talk about the scalability challenge and how essentially it can be solved with leveraging some of AWS's services. So
Awesome.
over
Thanks
to
a
you,
lot,
Tony.
Camilla. Thank you. So obviously there are multiple options for our customer and partner to run Kubernetes. There are multiple vendors providing different platforms to run and operate Kubernetes. But at AWS, we believe that AWS is the best place to run your Kubernetes cluster And the results speak for itself when 65% of organizations choose AWS to run their container based on a recent research from the Cloud Native Computing Foundation. And there's several reasons for this, which I'll talk in the next slide. Obviously, from the early day of container, started in 2015, we have listened to our customer, and we understand that running Kubernetes increase their operational overhead. And even though Kubernetes allow you to configure and run containerized application at production scale, team choose Kubernetes for its vibrant ecosystem and community, consistent open source API, and broad flexibility. But managing Kubernetes at scale is hard, as I have personally experienced that in the early day of 2015 and 2016, running version 1.1 to 1.4 of Kubernetes. Running a cluster at production scale is super complicated and require trained resource who spend a significant portion of their time managing upgrade, monitoring, and scaling the control plane, deploying and managing the lifecycle of operational software, and even more. Now, in addition, the operational team need to ensure that their workload are deployed in a secure manner, because security is always the top priority for everyone nowadays. Without exposure to known security vulnerability. So this further increased the operational overhead of running Kubernetes on your own. So all this effort does not really move the business forward. What you want is to focus your time on shipping feature, delivering a new product. So our customer want to focus on those domain where focus on application and idea that will allow them to deliver new product to the end user. This is why a lot of our customers have come to rely on Amazon or AWS to handle the undifferentiated heavy lifting of security and operating Kubernetes at scale, which I will unpack a little bit in the next slide. Now, the reason why Amazon Elastic Kubernetes Service, or Amazon EKS, is the most trusted and secure way to run Kubernetes is because EKS provide a flexibility of Kubernetes with the security and resiliency of being a AWS managed service. So as customer move a larger portion of their workload to Kubernetes, Amazon is meeting our customer demand with the Amazon EKS offering. And here's a few attributes that our customer has come to appreciate about our Amazon EKS. Firstly, we do not modify open source Kubernetes. And let me demystify this for you. So EKS is a fully upstream, certified, conformant Kubernetes. So anything run on Kubernetes will run on EKS. We even backport security fixes to ensure that we are consistent with open source. Secondly, we support upstream version for a longer time period. We support up to 4 versions of Kubernetes, with the latest being 1.21, which give our customers sufficient time to roll out upgrade, because I'm sure you could appreciate how fast the ecosystem is evolving nowadays. And as part of this, we even backport patches, fixes, and upgrade to Kubernetes version, even the one that the community may not currently support anymore. Thirdly, we provide a managed Kubernetes experience where we do a lot of work to select the right Kubernetes version, validate dependency to provide the security, stability, and operational excellence that our customer rely on us to deliver. Lastly, we want to reduce the complexity of Kubernetes operation. So what EKS provide is a managed experience with Kubernetes that enable application portability across the Kubernetes environment. So you don't have to worry about vendor login, and you can when you like to, you can choose to port your Kubernetes container everywhere you like. And so let's dig a little deeper into the flexibility that EKS provide in the next section. Now, so obviously, I'm going to touch a little bit on another container offer of Amazon or AWS, which is Elastic Container Service, or ECS, With ECS, simplicity is our top priority. With EKS, open flexibility is our top priority. Together with obviously security and reduce operational overhead. The reason is because we recognize that you may not be starting from scratch when you build on AWS Container Service. You may have been running your own Kubernetes cluster for a couple of years, and you have chosen Kubernetes as core of your technology and have existing tool. Now, EKS gives you the ability to bring the service you want and build a flexible environment. But of course, if you want to use EKS with all of the AWS service, you can do that too. And we continue to prioritize Kubernetes friendly integration with innovations such as AWS controller for Kubernetes, or ACK for short. Um, in the diagram, you can see that instead of using AWS code commit or code build, you can choose to use GitHub or Jenkins as your version control or CI/CD tool, and you can either using Docker Hub or Elastic Container Registry by AWS. The choice is yours. On the load balancing side, you can choose to go down with Amazon AWS native service like application load balancer, network load balancer, or you can go with Nginx and Traffic, which is open source solution. Or furthermore, you can use service mesh offering like AWS App Mesh or Istio. The choice is yours. So every single component in the EKS ecosystem is plug and play. You can replace it as you like. And last but not least, you have a choice to either run the Kubernetes on EC2 instance yourself, or run it as serverless option on a Fargate, which the AWS team will help you to manage the scaling, the patching of the underlying computing resource. So in the next section, we will discuss a little about some other option that you can run your EKS. So AWS started out with our fully managed EKS offering, but while we investing in making EKS on AWS the best place to run Kubernetes, we heard from several of our customers who has requirement to continue to run workload on-premise, and we're looking at Kubernetes as a way to provide portability across different environments. So we made two recent announcements in our reInvent that added two new deployment options to Amazon EKS. The first one is EKS distro. We open source the Kubernetes version that Amazon used for Amazon EKS. So with EKS distro, you have the exact same version of Kubernetes that EKS offer, the exact same major, minor, patch version. In other words, this is the distro of Kubernetes that power EKS. And we have essentially releasing the first time outside of EKS the result of all of the work, all of the hard work that AWS does to test, certify, and build an open source Kubernetes version when they are released. The second option is EKS, Amazon EKS Anywhere. And this enables you, our customer, to deploy Kubernetes workload on your self-managed hardware and get the API consistency with a EKS on cloud. Now, we offer EKS Anywhere to provide the tooling to install, provide upgrade, ongoing maintenance of EKS distro cluster. And EKS Anywhere will minimize the friction for our customer when you are ready to move those workloads to EKS on cloud. So those are the options that you can run EKS on, either on AWS, on-premise, or on Edge, on Outpost. Now let's touch a little bit on the native service integration, the AWS native service integration with EKS cluster in our next section. And as you know, AWS has the broadest set of service, technology, and tool to build application on container, as well as deep integration with open source and AWS partner technology like Splunk. So there's no one right way to build with Amazon EKS, and indeed our larger customer build in multiple ways. So we have the most choice in data plane option, including starting with Fargate or EC2, as I mentioned in the previous slide, with a choice of ARM processor or AMD or Intel, and special purpose hardware such as GPUs based instances in case you want to run machine learning workload or inference workload on your Kubernetes or EKS cluster. And integration with storage services like EBS, Elastic Block Service, or Elastic File Service, EFS, or FSX, which is a high performance storage option, is also give you a very broad set of options, whichever way you like. And when you use native AWS security and authentication and authorization service along with our well-architected framework, you can ensure that your cluster are configured securely. And that security and authentication service is our identity and access management, or AWS IAM. Obviously, you can also protect your application as the level 7 of OSI model using our web application firewall, or WAF. Um, and EKS automatically provision the AWS network service to provision load balancer, configure your VPC and set up Route 53 for external access. So you don't have to worry about all of those. Last but not least, EKS integrate with both AWS native and third-party tools like Splunk to provide multiple options for observability, which I'm sure Pamela will be able to walk you through in a little later. Now, next stop is about compliance with EKS. So many of our customers operate in a highly regulated industry, like, for example, banking, financial service, or health industry, or public sector. And we understand that customer need to operate under this regulatory guideline, and that's why we work really hard to make EKS compliant with all of this standard, so that our customer can rest assured that when they use EKS to run their application, they will already stay compliant on the infrastructure side without any additional effort. So with that, I'd like to summarize different options for you, our customer, as well as Splunk customer, to run EKS. So in the next slide, please. As you can see, AWS offer multiple deployment options for EKS, from the fully managed option to deploy EKS on Outpost with EKS Anywhere, or deploy it on local zone, which is an extension of our availability zone for any low latency, high performance workload. Or if you like, you can also deploy EKS version on your on-prem infrastructure with EKS Anywhere or EKS distro. So wherever you like, and we provide the tooling in EKS Anywhere for you as well. With that, I'd like to thank Pamela and Splunk team for the opportunity to introduce to you, the customer, about different options to run EKS. We obviously offer a lot more in terms of training, workshop, and material. So if you are interested, please reach out to me after the webinar, and I'll be more than happy to assist. Back to you, Pamela.
Awesome. Thanks so much, Tony. And I read a recent stat around 65% of organizations are using AWS to run their containerized deployment as well, which is awesome. So the second challenge that I wanted to talk about that has been highlighted is around monitoring, and essentially how to monitor at scale and operationalize Kubernetes. So we want to just look at essentially why traditional monitoring approaches will no longer work, and what are the challenges that organizations are seeing from a monitoring perspective. So firstly, from within a Kubernetes deployment, there are essentially a lot more components that are created and need to be monitored. So things like your VM, your Docker, your container runtime, and applications as well. So the scale of these components, as well as the multidimensionality of them, is challenging for traditional monitoring solutions to monitor. As well as this, all of these components are ephemeral in nature, so they're constantly changing. with containers consistently churning as well. So the need for a real-time monitoring solution needs to have the most accurate and up-to-date data for that visibility. As well as that, there's also the multiple data sources that you now need to consider. So things like metrics, events, distributed tracing, and often it can be difficult to monitor as you reside and depending on the source in different locations. So DevOps teams need to consistently switch between tools to essentially identify and detect and resolve incidents. And this can be further challenging with the containers consistently churning as well, leading to a longer mean time to resolution and a higher mean time to repair. On top of this, the lack of automation. So essentially with the more components and the multiple data sources within a Kubernetes environment, correlating all of this information and data manually will not work. There's essentially too many sources and too many components, but also there's a need to leverage data science, essentially AI and machine learning to help with identifying and surface problems and recommendations automatically. So when we look at each of these challenges, essentially a new approach is needed for observability. And I'm just going to build out this slide. Essentially understanding and baselining the health of your Kubernetes cluster is needed to understand, what is the health of your cluster and is it performing as it should, or are there any issues? You also need to have visibility into the different components that I touched on as well. So such as nodes and pods and how they are performing, and essentially the interdependent between each of these components. So how the performance of one can impact the other and the service that's being delivered. There's also a need to have granular logging within context as well. So the ability to essentially go between looking and analyzing metrics to actually diving into the logs to further understand root cause analysis, and the ability to do this with the context intact. There's also a need for real-time streaming analytics and alerting so that you have the most accurate and up-to-date data available to you and being able to alert on that in real time as anomalies are happening. On top of this, there's a need for AI-driven automation, and so to be able to leverage data science and ML to identify patterns and anomalies within the data as well. So these are essentially the baseline of the observability requirements that are needed to be successful in monitoring and observing a Kubernetes deployment. So if we look at Gartner, so Gartner has interviewed thousands of customers and come up with a best practice document for monitoring Kubernetes, and we've attached it in the resources as well. But essentially, in summary of the document, they've identified a few key requirements that are needed in order to be successful in monitoring Kubernetes deployment. So they've called out granular logging, automated service discovery, action-oriented recommendations in real time, and the ability to use analytics and machine learning. So as mentioned, we have that report attached in the webinar, but I'm going to go through each of these capabilities within the Splunk observability solution as well. So within Splunk infrastructure monitoring, which is part of our entire Splunk observability solution, we have an out-of-the-box Kubernetes navigator to essentially help you with monitoring a Kubernetes deployment. And it provides real-time observability into containerized deployments. Now, there are four key capabilities that are provided out of the box to help you with this. Firstly, we have our automated Kubernetes monitoring. So essentially how you get started with integrating and setting up and running and integrating your Kubernetes deployment into Splunk. It's a zero config installation leveraging a Helm-based installation. Within that, we have a dynamic cluster map. So leveraging our open telemetry collector to collect all of the data and components from your Kubernetes deployment, we automatically build out an entire view of your cluster and provide that hierarchical end-to-end view into your environment. From this high level view, you then have the ability to drill down within seconds to kind of identify or drill into an area of concern and really start to filter by any Kubernetes object, whether that be a pod, node, container, workload, or anything else. We also have, which is a really powerful feature, is our Kubernetes analyzer. And this enables, essentially starts to look at why or understand the why behind performance anomalies. And we provide essentially insights and recommendations using AI-driven analytics to precisely answer in real time why performance anomalies are occurring in your environment. And we then have the ability to deep dive into logs with context. And so go from looking at performance metrics and deep dive into the container logs themselves. So I have a few slides on each of these capabilities, and then I'm going to go through a real life performance issue within our demo environment as well. So I'll quickly go through each of the capabilities and slides, and then I'll jump into the demo environment. So as I mentioned, we have the fully automated Kubernetes monitoring. So a really easy way to get started and up and running with monitoring your Kubernetes environment. As I mentioned, it's a Helm-based installation, and we deploy our open telemetry collector to essentially discover all of your Kubernetes components and discover them, in real time, and all of the applications deployed as well. Once that's integrated into Splunk, we have out-of-the-box dashboards to get immediate value and insights into your entire cluster and environment. From there, you can then further create your own custom dashboards if you wish, but we have a lot of out-of-the-box content to get you started. As I mentioned as well, so we have the dynamic cluster map, which gives you essentially a bird's eye view or a 30-foot view into all of the clusters that are running in your environment, and it automatically discovers the Kubernetes components for you and instantly starts to monitor your entire stack. So from here, then you can start to filter per cluster, per pod, per node, and further deep dive into a more granular view. So as I mentioned, you have that quick drill down, so you can start from the high level view and then start to drill down into areas of concern or individual components and start to filter and narrow to a source of a problem. So you have the ability to go from a cluster to node to container and then into a workload itself. And as I mentioned, which Gartner has also called out, the ability to go from metrics and dive into logs within context. So we have the ability to seamlessly pivot from metrics into Splunk Core or Splunk Cloud, essentially our enterprise core platform, and look at the container logs to help you with further identifying root cause analysis and investigating into issues further. And as I mentioned as well, we have our out-of-the-box Kubernetes analyzer, which is using AI-driven analytics to automatically surface insights and recommendations to help you with remediations. So it will discover essentially performance anomalies that are happening across your entire stack, and that could be anywhere, and essentially highlight, detect patterns and highlight any anomalies and surface them in real time as they are happening. So it's a really, really powerful approach inbuilt to the solution itself. So before I dive into the demo, I just wanted to quickly cover off our real-time streaming architecture for metrics and analytics, and essentially why we built it this way. So there's a lot happening on this slide, but if I start from the left-hand side, we have our data ingest. So we can ingest data from any source in any location, so whether that be from cloud native services or from systems and devices running on premise. You have the ability to ingest metrics into the Splunk infrastructure monitoring to get real-time visibility into that system. We also then separate the metadata from the metric data, and we scale both of these sources separately, and that's to enable us to get to enable like high cardinality analytics, but also to ensure the most accurate data is being represented as well. A second key component is the ability we continuously adapt the jitter and the lag for each of our incoming sources from their inherent system. And this is to ensure the most timely and accurate rollups, analytics, and alerting. So we'll be looking at so if the data traversed over a network, we will take the logical time from when that data was ingested, which is really critical when looking at time series data. Thirdly, we store all of this data within persistent stores, and the ability to access historic data as well as live data enables you to get that real-time view across the data as it's happening, but also that historical view, which will also populate charts, alerts, or any automatic actions that you'd like to take as well. And then lastly, we have that live stream data that is consistently powering analytics and the rollups and any alerting that needs to happen as well. From that, we view that monitoring, you need to be in a place to understand and be able to act when needed. So we view that having an interactive visualization, so being able to explore your system and analyze the data is critical. Zero lag alerting, so there shouldn't be any unnecessary delays with data firing alerts, and you have the most up-to-date information, as well as a live data feed. So when you're looking to take any automated remediation, that you can trust the data that's coming in and take corrective action on that as well. So I'm just going to go into the demo and just do a quick time check. So I'll start off with looking at our Splunk observability solution. So I'm just in the APM view here at the moment. And as you can see, so for a bit of context, I'm just going to go through kind of an overview of the service that we're monitoring, and then we'll deploy a bad scenario into the environment and then start to troubleshoot and investigate it in real time. So at the moment, I'm essentially monitoring an e-commerce website that has a number of applications deployed on microservices, such as we have the API service, the checkout service, and the payment service. So in this initial glance, we can see that we have no errors at the moment, or we've only a handful of errors, and we have no kind of immediate concerns around our requests or latency. And essentially, we're monitoring red metrics in this instance, so everything to do with request, error, and duration. I'll quickly show you just an overview of this service. We have our API service, our checkout service, authorization, and a number of other services as well, such as payment, shipping, and some third-party services too. And looking at the legend, just to give you a bit of context. So the higher the circle, the more requests that are being run, and then anything with a red dot is starting to show some errors within that service itself. So you get a really a hierarchical view into the entire application and how it is running, and all the interdependent services as well. So I'm just going to navigate back to my home view, and what I'm going to do is deploy essentially a bad scenario into our environment, and we are going to watch that come in to our Splunk observability solution as well. So I'll just give that a few minutes to run. I'm just going to check the time. Yeah, so what I've done is essentially I've just on the Kubernetes environment that we're monitoring on AWS EKS, I've deployed essentially a bad scenario, and we're going to troubleshoot that issue now in our Splunk environment. So as I can see, just initially from deploying that in real time, you can see that our error rate has started to spike instantly. So we can see that we're starting to get a number of errors across our payment service. And we're also starting to see some errors across our API and our checkout service as well. And that's essentially the real-time streaming architecture that I was talking about previously in the slide. So instantly we can see that we're starting to get some errors across our application. We can see that our latency hasn't been impacted. It's been pretty consistent. And we also get a view into some of the business workflows and the error rate by them as well, which is a logical group of services to map out a business flow throughout the application as well. Looking further down, we can see each of the individual services, and we can also really quickly at a glance see that we're starting to get, as we've seen above, a spike in errors across our payment service, a spike in latency across our payment service, as well as some errors starting to show, which are also showing in our API service as well. So what I'm going to do is dive into this a bit deeper. And we have two ways we can go back to our overarching explore view of all of our services, or I can click on an individual one to dive in deeper. So I'm going to click on our payment service because we've seen the errors spike initially with it at the start, and we'll start to investigate and troubleshoot the issues as well. So instantly we can see that we're starting to get a number of errors. We've got the red circle that's indicating a number of errors are happening with this service. We can see our latency has started to increase. So within a few minutes, we've been able to kind of pinpoint the service that potentially has an issue. Another really powerful feature is the ability to actually break down this view of the service and see essentially what is being impacted as well. So we have the ability to break it down by a number of metadata points, so such as the environment, endpoint, HTTP method, and some of our infrastructure metadata, such as a Kubernetes node or pod name, as well as looking at some of the customers that may be impacted as well. So if I split by tenant, I can really quickly see that, which of our customers are being impacted by this error. So we can see that we've got gold and platinum customers starting to have issues. But one component I really want to highlight is the tag spotlight. So if I further dive into this a bit further, I can really quickly see from a kind of end-to-end view with this specific payment service, what requests, the number of requests that we have, and the number of errors that are starting to show. If I can quickly pinpoint to just focus on the errors. So this is where we start to really diagnose and investigate when we're having a performance issue. And I can quickly see from here, what container IDs are impacted, what image is running, what endpoint is being executed, what environment, what status code are we getting, and other kind of tags that are related to this specific service itself. So by starting from a hierarchical view, we're really showing how you can start to drill down into specific areas of concern and troubleshoot that incident further. But for now, I wanted to focus on the Kubernetes node. So I'm going to open this up and drill down further. So as I mentioned at the start of the session, we do have a number of out-of-the-box Kubernetes dashboards, which would be drilling down into this particular node here. But what I'm going to do is open this in our Kubernetes analyzer, which is what I spoke about at the start of the session as well. So by just further drilling down, I've been able to apply the context over and filter into this node detail dashboard, which gives me a lot of detail about this node, its properties, what workloads and containers are also running as well. So really quickly, I can see the name, the ID, some of the CPU, memory, and network insights across this particular node itself. And if I look down before, I can actually start to look at the payment container that's running on this node that seems to be having errors. And by clicking on it, I can really quickly get a view into this particular container. So I can see the name of the container, the pod that it's running on, the node that it's running on, what CPU is being used, what memory is being used, and what the memory limit as well is. So an initial look, there doesn't seem to be too much wrong with this particular container, but what I can do from here is dive in and see if there's anything in the container logs as well. So from this view, I can quickly deep link into Splunk Cloud and have a look at the container logs in further detail as well. to log in. So from here, I've actually been able to go from metrics and apply that context straight into our logging environment, and without having to write any SPL or any search language. And I can quickly see all of the events that are associated with this particular container. And by investigating and having a look at some of the events, I can see that we are starting to get some out of memory error messages and events appearing for this particular container as well. So each of these are giving us an error message out of memory. So what I can do is go back to look at our node again. And if I look at some of the other containers that are running, I can see that we also have this K-Harman robot container also running. And looking across, you can see that it is actually consuming most of the memory for this node. So let's dive into that one a bit deeper. So by clicking on this container, I can look up and see the container properties again. So you can see the pod, the node, as well as the CPU. And we've essentially kind of found our problem here where the memory limit has not been defined. So this is a well-known issue that can occur, and SRE teams would be familiar with. So by not defining the memory, this particular container is consuming all of the memory that's assigned to this node, which is then resulting in the payment service not getting the resources that it needs. So this is often known as the noisy neighbor problem, where another workload that's running on the container is actually consuming all of the services. And it would have been really difficult to identify this in real time and remediate without having this visibility into all of the containers that are running, as well as a real-time view of impact across the application as well. So I'm just conscious of time, so I did want to show you guys really quickly as well, as part of the Kubernetes Navigator. I did mention about the dynamic cluster map. So once you deploy the OpenTelemetry collector, it identifies all of your Kubernetes components and builds out this hierarchical view of your entire environment. So this is all of the clusters that are running within my organization, and I can quickly filter to clusters that I want to drill down and analyze further. So if I drill down into the cluster that we were looking at earlier, K-Harman, I can really quickly see, all of the nodes that are running within this cluster, all of the pods, and also be able to visually see what ones are having issues. And by clicking on a particular one, I can also then open up our analyzer as well, which I spoke about earlier, which is that AI-driven analytics that is out of the box within Kubernetes Navigator, which helps to identify any performance anomalies and patterns, and then highlight recommendations and insights based on that as well. So it's a really powerful capability that's inbuilt into the Kubernetes Navigator. So you can see that we have suggested issues with containers that are relating to high memory nodes from here as well. From here, I also did want to show you guys, just before I switch back to the slides, that we do also have some of the out-of-the-box Kubernetes dashboards that does come once you set up your integration. And so by navigating over here, I can get out-of-the-box visibility across my entire Kubernetes environment and clusters, and looking at individual pods and nodes as well. So if I was to filter, I'll just take off the filters here, and I can get a really quick insight into number of metrics around my cluster, the number of nodes that are running, as well as the pods and CPU usage, and other key stats to help me ascertain the health of my cluster as well. And we do have a number of inbuilt out-of-the-box dashboards that can help you with that visibility, and you can also customize them as well. So I will just quickly navigate back to the slides. I only have a few to cover before we switch to the Q&A. But essentially, by deploying and leveraging Splunk infrastructure monitoring, customers have got unique value from seeing essentially 8 times faster code releases and 36 times faster alerting, and also the reduction of maintaining alerts as well, and also an 80% increase in mean time to detection, so essentially catching them problems before they impact your service or impact your customers. 2 customers that I did want to highlight that are leveraging Splunk and AWS EKS, one being care.com, who have leveraged our infrastructure monitoring, especially when it comes to migrating workloads to Kubernetes. So their operations teams are able to really quickly identify any issues and essentially remediate them quickly, leveraging the Navigator on our infrastructure monitoring solution. And another customer I did want to call out as well was BidMotion, which essentially are leveraging infrastructure monitoring to monitor all of their AWS services and how they are performing. Most of their applications are now deployed on EKS, and our Kubernetes Navigator from the Splunk side helps with that, cutting through that complexity and getting that hierarchical view into their entire health of their Kubernetes clusters, and being able to kind of pinpoint and remediate performance issues as well. So sorry I did rush it a bit towards the end, but I did want to leave time for some Q&A. But before I do so, I would encourage everyone to have a look on our website on getting started with infrastructure monitoring, and installation is really quick, and you can leverage a lot of that out of the box capability and content that we do have with infrastructure monitoring as well. And also I would encourage you all to leverage some of the resources that we've put on in the handout section as well. But I will leave it there from me, and if there's any questions, please feel free to post them in the chat and we can go through a live Q&A. But thanks everyone for your time, and hope you enjoyed the session.
Well, thank you so much, Pamela. And if I could now at this point invite Tony to join us back for some questions, but we'll go ahead and start with this one right here. Why would we choose EKS Anywhere or EKSD over managed EKS, and what are the cost implications?
I think that's a question for Tony.
Tony might be having some difficulties, so let's just let's move on to the next one. So is Splunk infrastructure monitoring a different product from Splunk?
Oh, yeah, that one's for me. Yeah, so Splunk infrastructure monitoring is, it's part of our entire observability solution within Splunk. It does sit a little separate to our enterprise data platform, but both of them have a very tight integration. So you would have seen through the demo where we went from looking at, monitoring metrics and diving into the logs in granular detail. So there's a really tight integration there between both of them.
All right, and for our next question, can OpenTelemetry monitor workloads deployed on Kubernetes?
Yes, it can. So you would have seen, so the demo environment that I went through essentially had deployed the OpenTelemetry connector onto Kubernetes, and we were capturing a lot of detail around the information around node pod and workloads. So we did have a few dashboards that gives that visibility into the workload detail as well. Unfortunately, I didn't have time to show that today, but there is that capability there as well.
All right, and another question asks, for data ingestion from Kubernetes, does Splunk Forwarder need to be installed in Kubernetes image?
No, so we can leverage the Open Telemetry Collector. So that is our kind of primary way of getting data from a Kubernetes environment. And it's essentially vendor agnostic as well, so it can capture all of the data that's needed, particularly for Splunk infrastructure monitoring.
Awesome. And it looks like we might have some of our technology fixed. So I'll repose our first question. Why would we choose EKS Anywhere or EKSD over managed EKS, and what are the cost implications?
Hi, this is Ming Wei from AWS here. I'm also a partner solutions architect. I think Tony is having some technical issues, so I'll take this question for him. So in general, it's really up to the customer on the level of control they need. That's really whether they need to use the EKS console as a way to monitor their EKS deployment. Or do they want to fully control the entire deployment where they can just use EKSD? So that's really it's really totally up to the customer in terms of the different level of control, in terms of where the control plane is and where the data plane, where they compute, what level of controls do they need at each layer. So and regarding the cost is all this pricing information are available on the AWS website. So in general, for EKS Anywhere and EKSD, there's no pricing involved. But if today, let's say you choose EKS Anywhere, you can also opt to go for a support plan where you can pay for that level of support on your clusters. So all these pricing information will be on the website, and I will be able to paste a link to the question directly. Yeah.
Great. Thank you so much for jumping on to answer that. So at this point, we are approaching the top of the hour, and we did get plenty of good questions in. So we will be sending those over to the people at Splunk, and I'm sure they can get those answered for you as soon as possible. At this point, I'm going to launch a quick quiz, or a quick poll rather. So feel free to take a look at this and answer it while I read out our intro today. But the question poses, where are you in your continuous delivery journey? A, currently outgrowing existing tooling. B, anticipating outgrowing existing tooling in the next 12 months. Or C, satisfied with existing CD tooling. So I appreciate each of you for answering that poll. And just a quick reminder that today's session was recorded, so if you missed any or all of the presentation, it will be made available to rewatch. Following the webinar, you will receive an email with a link to access the recording on demand, and you can also find the recording living on the DevOps website. Just visit devops.com/webinars and look in the on-demand section. It will be waiting for you. Now on to the 4 winners of our $25 gift card drawing today. Our first winner is Mohan V. Congratulations, Mohan. Our second winner is Ashish A. Congratulations, Ashish. Our third winner is Travis K. Congratulations, Travis. And our fourth and final winner is Rahul C. Congratulations, Rahul, and the 4 of you for winning our $25 Amazon gift cards. Pamela and Tony, thank you again so much for taking the time to put together this presentation and this demo. And I'd also like to thank each of our audience members for staying here for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everybody.
Thanks, Cody. Have a great day. See you.